In this video, we're going to look at a technique called cross multiplication. Okay, now this technique can be used for situations where you have a fraction equal to a fraction. Now, let's just take two equivalent fractions and we'll show you what we're talking about. So let's say, for example, we know that 2 over 4 is equal to 5 over 10. Okay, now we also know that 5 over 7 is equal to 15 over 21. Now, what do you notice when you multiply together the diagonals? 4 times 5 is 20. 2 times 10 is also 20. And 20 is equal to 20. Let's look at this one here. 5 times 21, that's going to be 105. And 7 times 15, that's also 105. And again, 105 is equal to 105. Now, big deal, you might say. What's the point in this? Well, this technique comes into its own when you're faced with questions where you've got algebraic fractions involved in equations. Now, it only ever works when you've got one fraction equal to another fraction. Anything else, unless you can render what you're given into that format, one fraction equal to another fraction, you cannot use it. So let's look at 4 examples and we'll see what we could do. Now let's say you've got the equation and you're asked to solve u over 4 is equal to 3 over 2. Okay? And let's say secondly that you're asked to solve x over 10 is equal to 7 over 2. Okay? Now, using cross multiplication, u times 2 is 2u. 3 times 4 is 12. And we know that the diagonals have to be equal to one another. So this then gets everything onto one level. No fractions, nothing complex. Divide both sides by 2. What you do to one side, do the same to the other, and you get your solution. U is equal to 6. Okay? Now for this one, cross multiplication, x times 2 is 2x. 7 times 10 is 70. These products must be equal to one another. Again, dividing both sides by 2. And you end up with a solution of x equals 35. Okay. Now let's look at another couple of examples. Okay. Now, let's look at this one. Let's say we've got 2 over 2x minus 1 is equal to 3. And fourthly, let's say we've got y equals 1 over 3 brackets y minus 2. Now, can we use cross multiplication with these questions? Because remember, we need a fraction equal to a fraction. And we don't have that. But we can render it in such a way as to give us a fraction equal to a fraction. Because if I leave the left-hand side here the same, then I can write the right-hand side as just 3 over 1. Because that's what 3 is. 3 divided by 1. And then if I do cross multiplication, 3 lots of 2x minus 1, that has to be equal to 2 times 1, which is 2. And then tidying all that up, I get 6x minus 3 is equal to 2. If I add 3 to both sides, they cancel out. So we end up with 6x is equal to 5. And then dividing everything by 6, I find that x is equal to 5 over 6. Okay. Now let's look at this one. What have we got? In question 4, we've got y equals a third of y minus 2. Now, when you find a third of something, what are you doing? All you're doing is you're dividing by 3. So I can write that as y minus 2 divided by 3. And y, as we said earlier on, is just y divided by 1, because anything divided by 1 just gives you itself. Now, let's do some cross multiplication. Y minus 2 times 1 is y minus 2. Y times 3 is 3y. And these are equal to one another. Now, all I'm going to do is I'm going to take y from both sides, so that I end up with letters on one side, numbers on the other. They cancel out. I'm left with negative 2 on the left, 2y on the right. Now, if the left-hand side is equal to the right-hand side, then the right-hand side is equal to the left-hand side. And then if I divide both sides by 2, we end up with a solution of y equals negative 1. Okay? So that's cross multiplication, and there you see how it can be applied. So we can easily transform equations that look a bit complex into something that is definitely easy to solve. Remember, you can only use this technique when you have a fraction equal to another fraction. It doesn't work for anything else. Okay, so let's have a look and see if you can do a few questions yourselves. Okay, so here's 4 questions for you to do. And we have, let's say, if we do, so we'll ask you to solve these 4 questions. Let's see if you can do y over 8 is equal to 3 over 2. And we'll say m over 6 is equal to 5 over 3. And we'll say question 4, question 3 even, we'll do b minus 1 over 3 is equal to b over 5. And finally, question 4, you can do x equals 3/5 of x minus 1. Okay, so there you have 4 questions. Pause the video, work them out, and then check and see if your solutions are the same as what we've got. Okay, so if I move these down, okay, just now, we can deal with questions 1 and 2. So again, cross multiplication, that gives us 2y is equal to 3/8, which is 24. 2y is 24, divide both sides by 2. I end up with y equals 12. Okay, for these, cross multiplication, 3 times m is 3m, 6 times 5 is 30, so 3m is 30, divide both sides by 3, I end up with the final solution of m equals 10. That's the first 2. Now let's look at questions 3 and 4. Let's do 5 times b minus 1. So 5 brackets b minus 1. Remember, you're multiplying everything here by 5, not just the b, but the b and the negative 1. And then that's going to be equal to 3 times b. Multiply the brackets, we get 5b minus 5. And that's equal to 3b. And then, what can we do? Well, I'll add 5 to both sides first. So they cancel out. So I end up with 5b is equal to 3b plus 5. And then, if I subtract 3b from both sides, I then end up with letters on one side, numbers on the other. And that leaves me with 2b on the left and 5 on the right. Divide both sides by 2. And we end up with b equals 5 over 2, or 2.5 if you like. Okay, so last one. Remember, this is just the same as x over 1. And the right-hand side is equal to 3 lots of x minus 1, which, if you like, is 3x minus 3 divided by 5. Because when something is multiplied by a fraction, you just times by the top, divide by the bottom. That's what we've done here. Okay, now we're ready to do our multiplication. Okay, so we'll say 5 times x is 5x. 1 times this, 3x minus 3, is just 3x minus 3. And you notice how much easier this is to work with than what we had before. So now all we need to do is get letters to one side, numbers to the other. So we take away 3x from both sides, and we end up with 2x on the left, negative 3 on the right. Divide both sides by 2, and you end up with x being negative 3 over 2. Okay, so I hope that technique will stand you in good stead the next time you're faced with an algebraic equation where you have one fraction equal to another fraction. So remember, multiply the diagonals and the two products will be equal to one another.